union types. This time I mean it. Let's talk about them and what they are, and not review stuff. Okay, so we've talked about a username. And I'm going to imagine you might go ahead and somebody else may have written a function that maybe goes and makes a user, maybe takes something from a web form, makes a query to a database, and tries to return a username. And that's fine. It's like, okay, what type should I use to represent that? Oh yeah, we have this new type username. Gosh, except, you know, when I think about what comes back from the database, it's not just a username that might come back. It might be no result. I might be searching for somebody who doesn't exist. And so, yeah, there's a more nuanced thing. I want to go ahead and say, I want to go ahead and represent something as a username or an indication that it wasn't found. Now, if you use Java, you're like, well, duh, use null for that. That's what null is used for, right? Yeah, well, when you're doing that, you're actually using a union type in a more limited way, because I don't want to do that, partly because what might come back from the database might be, hey, there is no such user, and I want to represent that somehow. Also, I want to be able to represent another option, another variant of an answer. Could be, hey, that user exists, but they have said that their information is private and do not want to give it out. You can't get their email address, sorry. Okay, so, gosh, I want to be able to represent, and I'm going to stop there. I could think of maybe some other variations. I need to be able to return something from a function that's something that either be a valid username, an indication that there is no such user, or an indication that the user exists but privacy conditions apply. Okay, I guess if I'm using a language like Java, I'm sort of encouraged to say, hey, I can only list a return type like string. I can't have 3 different possible return types. So it's really a string or a username and 2 sentinel values. What I'm tempted to do in Java is say, hey, I'll return either a username or I'll return the string private, or I'll return the string does not exist. Okay, with all run together in camel case maybe. Well, there's a big problem with that, right? Hopefully you're onto me. What happens if you make a query and you get back private? Is that their username, or is that an indication that the information is private? You can't tell until you try emailing and get a bounce back, or you don't. Yeah, we don't want to use sentinel values that can interfere with valid usernames. Now, we actually have a little extra thing. We can say, hey, I know this username can't be 14 characters or more. Maybe I'll make those 2 sentinel values for the special cases, make them be really long and more than 14 characters. Okay. Yeah, that feels a little bit icky. I guess it might be this, might be a valid username like iBarland or Z23456, or it might be private space. Yeah, that just feels yucky, you know? I guess I have a message that has spaces in the middle of it. Yeah, it doesn't feel right. Yeah, I know I could. In Java, I probably would, because I'm so lazy, because it's harder to do the right thing in Java. We'll talk later again about the union types in Java. I want a union type. The answer can be one of these, or one of these, or one of those. And that's a union type. I'm taking the union of 3 sets, if you will. In this case, it's a little bit odd. 2 of those sets are singleton sets, 2 individual sentinel values. But, okay, we'll come back and explain that a little bit more. So I want to go ahead and have a new data definition, a lookup result, the sort of thing you might get back if you make a database query, okay? And it can either be a valid username or, and I'll go ahead and use this, I'll go ahead and say, or it might be the Boolean false, okay? And that's used to, the interpretation of that is that no such person is in the database. Or it could be the symbol private. Again, Racket has symbols, and I think that's a nice thing to use here. It's definitely not a string, so they're really not similar to a valid or an existing name. So great. Here's the type I might get back. If I make a database query, I might get back a username. I might get back false. I might get back private. I'll never get back true. Why not? Because if I look at my data definition, I'm like, hey, there's only 3 options here. And we can give several examples. Either a username. Hey, I already have examples of the username up here. Copy, paste. In addition to any of those being things I might get back false. There's only one example for me to put there. And I might give back take private. Okay, so these are examples of the data for a lookup result. This again is a sort of a little bit more complicated type. It's more than just a username. It's what you might get back if you ask about somebody in a database. It would be the way to represent that answer. Okay. Suppose we're a function that is given that. Okay, maybe we're the thing that gets the answer back from the database, and we now need to present it somehow. Okay, so that's what I want. I want to go ahead and write a function called, well, let me just say here, lookup result again is a union data type. What's one way to tell that Barland wants you to use a union data type? In a data definition, we say or in big capital letters here. Okay, or meaning union. One of these or one of those. Cond in Racket, the if-else if that we mentioned briefly, cond is the natural way to handle a union type. So, okay. Let's go ahead and write a function which, if it's given a lookup result, goes ahead and gives back a string suitable for splicing into a web page or something like that, or an email or a text or something. Okay, so here's what we'll say. You go ahead and somebody else makes a query. They get something back from the database, and they give that thing from the database to you and say, hey, give me a string I can put into the web page or a text or something like that. And I'm like, okay, and in particular, we want to either have the answer be in a Radford email address. It's always going to be a string. It's either going to be a Radford email address, or it will be the particular string no such person, or it will be the particular string information not published. This is the sort of thing I might give you on a homework or an exam. Write a function which, given a lookup result, returns a string of this form. Okay, so what is the first step of our design recipe? Write unit tests. Okay, we are, by the way, let me just emphasize on the design recipe, steps 1 and 2, we do that once to define the type of data, and then even if you write 5 different functions that all handle these lookup results, we'll do steps 4, 5, 7, 8, 4, 5, 7, 8, 4, 5, 7, 8, 4, 5, 7, 8 over and over and again for each one of those different functions. So, but we don't repeat steps 1 and 2 once we have a data definition that works. Okay, and here's our step 2 was examples of the data. Let's look up result. We can go ahead and write test cases for it. Lookup result, I'll call it lookup result to string. I had to come up with some name for it, and so I came up with that name. Name might be specified in the homework often, but if it's not, come up with a good name, and I think lookup result to string is a pretty good name. Okay, what happens if you give me false? Well, I just read the spec and knew that answer. This is a runnable test case. Cool. Okay, put my check expect. Go ahead, and what happens if you give me private? Great, I'll check that. What happens if you give me iBarland? Where'd I get these from? I just read off my examples of the data. Good thing I did step 2, because I'm able to use that and copy and paste, and very little thinking about what should I use as my test inputs. I'm just going to take them from step 2 of my design recipe. So, okay, great. So that's test cases. That's step 4. What do we do? What's step 5? By the way, I could use some more. Back to the testing here. Test cases. I'm going to sort of point out that, I'm going to do this is white box thinking. My program is going to do one thing for false and do something for private, but if you give me a string that is a valid username, I'm probably just going to be doing some string appends to get an @Radford.edu at the end of it. And, it doesn't really matter if it's a string with 7 characters or 13 characters or 1 character and I've had digits on the end. So my white box testing, I'm like, and I'm okay with this for this class, that's good enough. I'm not going to write more test cases. If I were working at an actual job, I probably would take these examples of the data and just take the extra 7 minutes or 12 minutes, 7, probably 4, copy and paste those and put them in all those as with the @Radford edu, and then I'd have good runnable test cases that really test all the sorts of boundaries. In this case, for this class, I'm happy with these check expecs. Okay, let's go ahead and step 4 of the recipe. What's step 5? Think about it, pause, look it up. Or commit it to memory is what you need to eventually do. Great, you were unpaused. We're going to go ahead and write the purpose statement. Oh, hey. Returns. Yeah, your purpose statement can often be copy-pasted from the problem statement if you're in a class. If you're so lucky to have something given to you in a class, the purpose statement is often spelled out right there. If your boss just given it to you in words or some helper you're writing, you have to come up with your own phrasing of the purpose statement. What is this function? Given a lookup result, I don't need to say write a function which, that's already obvious, this is the purpose statement. Given a lookup result, that's going to be in the signature, okay? So what is this function going to do? It's going to return a string representing the lookup result suitable to show an end user. And I'm going to leave a little bit back. I know that I could copy and paste even more, but those details might change in the future, and I want to make my purpose statement, what is the overarching purpose of this function, not the nitty-gritty of everything it does. People can look at the test cases if they want to see some nitty-gritty of what it does in certain examples. Okay, that's my purpose. What is the signature of this thing? So first of all, it's going to go ahead and look up result arrow string, and that's one of those things where, what is the signature of that thing? Well, it's lookup result and returns a string. So, okay, and the header, finally, the header is just that define with the right things. Lookup, the one thing we add in the header is, what should we call the lookup result that comes in? And I'll just call it LR for lookup result. Okay, and if I really want to stub it out, I can go ahead and stub it out and say blah blah right now. Stub. Okay, and why do we do that? I can now run my check expecs. Okay, so go ahead and try that. Let me go ahead and comment out the stuff that's already in the rest of this file. Going to run, and I hope to see that, hey, ran 3 tests, 0 of them passed, and here are my failures. Stubby stub is different from no such person. Stubby stub is different from I borrowed it at Radford. Yeah, okay, awesome. But I know that I haven't goofed up yet. I don't have any missing parens yet. Compile early, compile often, run early, run often. Okay, so we've done we've done and now we're just left with complete the code. I'm told you all wanted short videos, so we'll go ahead and break that last bit, completing the code, into its own little short video.